Hey guys, welcome to question FM344 of the Further Maths 4 to 5 study guide. This question reads, Sam is navigating through a South American jungle. He travels from X to Y and then from Y to Z. Sam's path is shown in the diagram below. So we've got X, Y, and Z. Sam traveled 111 meters on a bearing of 58 degrees from point X to point Y. Sam got lost on his way to point Z, but knew that point Y was 147 meters away on a bearing of 328 degrees from point Z. Question A wants us to figure out what is the bearing in degrees of point Z from point Y. So the key word here, guys, is point Z from point Y. So what we've got to imagine is that we're standing at point Y. We want to find the bearing, so we want to find that angle there that goes straight from north around to whatever that bearing would be. Now, an easy sort of like little trick is, since we know the bearing of Y from Z, we can look at this bearing, which is 328. That's over 180 degrees. So if we take our 328 and minus 180 degrees from that, we'll get our bearing going the opposite way. So minusing 180 from 328, we should get 148 degrees, and that is going to be our bearing to Z from Y. Part B then says, what is the angle theta in degrees? And we're looking at this angle down here. So I'm going to start off by drawing just a little bit of a diagram that will maybe help make a bit more sense out of this. So let's pretend that we've got point Y here, that's our point there. And we've got the line that's going off towards Z, and we've got the line that's going off towards X, and we've got this unknown number here. Now, what we know so far is that Z is on a bearing of 148 degrees from Y. So we could take this angle here and say that's 148 degrees there. And then what we can also do to help us figure out this question is find the bearing of X from Y. So once again, using that same theory, now 58 is actually below 180 degrees. So instead of minusing 180 degrees, this time we're going to add 180 degrees. So if we have a bearing that's below 180 degrees, we add 180 to get the bearing going the opposite way. If it's above 180 degrees, we subtract 180 degrees. So here, we should get a bearing from Y to X of 238 degrees, which means that we know that this is going to be 238 degrees all up. So to find theta, we've just got to take 148 degrees away from our 238. So we end up with 238 minus 148, and we should be left with 90 degrees as our value for theta. Cool. Part C. Part C goes on to say Sam will take a straight line path from point Z back to point X. What is the distance in meters that Sam will have to travel to return to point X? Round your answer to the nearest meter. So now I'm going to draw another little diagram. We've got a bit of a triangle happening. And what we know about this triangle is that this side is 111 meters, this side is 147 meters, and this angle here is actually a right angle, because we found it to be 90 degrees before. Our unknown, X, this is what we're trying to find, is the straight line distance between X and Z. So since this is a right angle triangle and we've got two side lengths known and we're trying to find the third unknown, we can use Pythag. So our base formula, c squared equals a squared plus b squared. Rearrange a little bit. And now substituting our values, we should get a straight line distance of 184 meters. Question D then says, what is the bearing in degrees of point X from point Z? Round your answer to the nearest degree. So creating another triangle just to help us out here. We want to figure out what the bearing is from Z to X. All we know about it so far is that it's got to be less than 328 degrees. If we create another of these triangles, remembering that this is a right angle triangle, 111 meters, we've got 147 meters here, and we did find this other length down here to be 184 meters when we rounded to the nearest decimal place. Sorry, to the nearest whole number. If we can find this angle here and subtract that from 328 degrees, we should actually be left with the bearing. So if we have 328 minus theta, that should leave us with our bearing to X. So let's figure out what this angle is. How we're going to do this is by recognizing that this is 90 degrees and using our sine rule. So if we relate these two sides and we say that sine of 90 degrees over 184 is going to be equal to sine of theta over 111. Rearranging for theta. At this stage you could just solve for theta, just have theta equals, I'm going to show the rearrangement. Rearrangement is going to be sine -1 of 111 times sine of 90 degrees over 184. Plugging this all into a calculator should end, before we plug this all into a calculator, going back to our original formula, this 328 minus theta gives our bearing. So we're going to find our bearing by taking 328 degrees and subtracting this angle, sine -1 of 111 times sine 90 over 184. Plugging all that into your calculator should leave you with an answer when rounded to the nearest whole degree of 291 degrees. So we've subtracted this little angle here, which was expressed like this, from the full 328 to leave us with that bearing there. If you guys have any questions about any of these questions, please leave them in the comments below. Otherwise, I will see you in the next video.